everyone, Assalamu alaikum, and thank you people to join my channel. Today our topic is quasi concavity of the utility function. When we are discussing about the consumer theory, and we know that we have some utility functions by which we basically want to analyze our data, we are interested to analyze the consumer behavior. So we learn that after the different shapes of the indifference curve, we are discussing about the utility function, and we know that the utility function should be the quasi concave, and so our indifference curve will be the follow the strict convexity, and which is the well defined behavior of the consumer. So for the checking of the quasi concavity of the function, whether our utility function is quasi concave or not, so we can use the different techniques. जैसे कि हमने देखा था कि अगर हमारा यूटिलिटी फंक्शन सिंगल वेरिएबल पे डिपेंड करता है, लेट्स सपोज अगर वी से दैट आवर यूटिलिटी फंक्शन इज बेसिकली is the utility function of the let's suppose x, only one commodity we are using. So very simple, we can use a simple derivative approach. The first derivative and the second derivative, first derivative should be the greater than, and second derivative should be the less than. So we can say that the function is following the concavity. So we use the different techniques of the concavity as well, where we define that whether we have the two variables, so we can use the concavity. Now we are going to discuss the generalization. Let's suppose if our utility function is basically is the utility function of the different goods. Let's suppose x1, x2 up to xn. So we can simply say that this is the basically a vector. The whole vector is, let's suppose we have the different commodities. So let's suppose x star. So when we are discussing in the end products, so we may have 4 different types of products, 7 different types of product, 10 different types of product. So our utility may also depends on the different consumption of the different product. हम यहाँ पे जानना चाहेंगे, जब हम जनरलाइजेशन की तरफ जाते हैं तो हमें यूज़ करनी पड़ती है टेक्निक्स ऑफ द बॉर्डर्ड हेशियन. So what is the bordered Hessian? First we discuss that. First of all, that's when it is basically a Hessian matrix, and Hessian matrix can be explained as that where the H is used for the Hessian, and this is a matrix in which basically we do this. Number one, we have a function that mean we represent by the f, और सबसे पहले हम उसका एक border बनाते हैं, border of the first derivative of the function. Let's suppose the matrix will start from the 0, and this is basically the f1, this is basically the f2, and up to fn. So means these are the commodities 1, 2, 3, 4 up to n. So first of all, we will take the first derivative of our function with the special derivative of our utility function with respect to commodity 1, then commodity 2, and then up to commodity n. So ये तमाम first derivatives हैं, और by using the first derivative हम जो है उससे border set करेंगे. Similarly, we will use the same technique here, f1, f2, and up to fn. So जब first डेरिवेटिव से हमने बॉर्डर सेट कर लिया, अब यहाँ पर हम जो है वो क्रॉस डेरिवेटिव लेना शुरू करेंगे. सो बहुत आसान है, ये फर्स्ट है, ये फर्स्ट है, तो दैट्स मीन दिस इज द फर्स्ट, ये फर्स्ट है, ये सेकंड है, तो दैट्स इट्स मीन द फर्स्ट 2, एंड अप टू दिस इज बेसिकली द फर्स्ट कमोडिटी एंड अप टू द एंड कमोडिटी. ये हम यानी कि जो यूटिलिटी फंक्शन का डेरिवेटिव फर्स्ट से लिया हुआ होगा, अब हम उसी यूटिलिटी फंक्शन को फिर सेकंड कमोडिटी से लेंगे, उसी यूटिलिटी फंक्शन को फिर थर्ड कमोडिटी से लेंगे. तो डिफरेंट हमारे पास क्रॉस डेरिवेटिव्स, हमें सेकंड डेरिवेटिव और क्रॉस डेरिवेटिव्स मिलना शुरू हो जाएंगे. बॉर्डर डिसीजन बनाना बड़ा आसान है, हम बॉर्डर की मदद से बाकी डेरिवेटिव्स को निकाल सकते हैं. ये 2 है, ये फर्स्ट है, तो हम इसको 2, 1 लिख देंगे. ये 2 है, ये 2 है, इसको हम 2, 2 कर देंगे, और ये 2 n कर देंगे. सिमिलरली यहाँ पर हमारे पास n टाइम प्रोडक्ट चल रही है, तो n प्रोडक्ट का डेरिवेटिव जो हुआ होगा फर्स्ट उसको फिर फर्स्ट से करेंगे, फिर इसी तरह से n को 2 से करेंगे और फिर फाइनली आखिर में सेकंड डेरिवेटिव आ जाएगा nth प्रोडक्ट का। ये बॉर्डर्ड हेशियन का मैट्रिक्स है फॉर n प्रोडक्ट्स। हम फॉर आवर ईज we usually discuss the cases of the two goods. So when our utility function is the utility function of the commodities x and y, let's suppose, तो हम इसका बॉर्डर्ड हेशियन मैट्रिक्स कैसे सेटअप कर सकते हैं हम उसको देखते हैं। बॉर्डर्ड हेशियन मैट्रिक्स सेटअप करने के लिए लेट्स सपोज सबसे पहले हमारे पास h होगा और हम ये कहेंगे कि ये हमारा 3/3 का मैट्रिक्स बनेगा। कैसे हम देखते हैं, फर्स्ट टर्म 0 होती है एंड देन फिर हम बॉर्डर सेटअप करेंगे तो डेफिनेटली इसमें 3 रोज बनेंगे तो ये 3/3 का बनेगा। वो कैसे, हम यूटिलिटी फंक्शन को पहली कमोडिटी x के ज़रिए से फर्स्ट डेरिवेटिव लेंगे, फिर यूटिलिटी फंक्शन को हम दूसरी कमोडिटी y के ज़रिए फर्स्ट डेरिवेटिव लेंगे। सिमिलरली यहाँ भी हमने फर्स्ट डेरिवेटिव से अपना बॉर्डर सेट करना है। सो व्हाट हैपेंस बेसिकली, सो व्हेन वी हैव द टू कमोडिटीज आवर मैट्रिक्स विल बी 3/3 एंड देन ux एंड uy। और सिंपली हमने कहा था कि जब आप बॉर्डर सेटअप कर लें तो रिमेनिंग टर्म्स को बनाना बड़ा आसान है। वी सिंपली यूज दीज टेक्निक्स x and x, so this will be the second derivative of the x, and now here xy, the first derivative of the utility function with respect to x, then it is now going to be taking the derivative with respect to y. This basically it's called the cross derivative. Now the yx, because first derivative is y and then the second derivative of the utility function with respect to y. So we will use this Hessian matrix for two commodities case. Now this is a matrix. How we check the quasi concavity by using the bordered Hessian. ये bordered Hessian हमने बना तो लिया, अब हम मेथड कौन सा यूज़ करेंगे जिसके ज़रिए हम अपनी quasi concavity को easily चेक कर सकते हैं। So basically what happens, we are using basically the minor concepts of the minor. How can we use in the matrices the minors? We will make first of all h1, h2, h3, h4 up to hn. So how can we make, let's suppose the first term is basically the h1 and if we want to take the h2, so that means it will be the matrix of the 2/2, mean 2 rows and 2 columns. So this will be matrix up to here. And now if we are going to discuss the h3, if we have the two goods, so our matrix will be like this. So up to like this we will have the n matrix. So what is basically happening here, we can simply we can see that कि हमारे पास 2/2 का केस है तो 2 गुड्स का केस है तो 3/3 का मैट्रिक्स बनेगा और वी विल हैव बेसिकली 3 डिफरेंट हेशियन डिटर्मिनेंट्स। सो नंबर वन h1 is equal to, let's suppose 0, so 0 we will not see here, we will start from the 2, h2, and h2 we will take the basically derivative of the 0, ux and uxx, okay, and then you will make the Hessian 3 in which you will make 0, ux, uy, ux, uy, uxx, uxy, uyx and uyy. So it is same like this. So आखिर में हेशियन मैट्रिक्स अपने आप को रिपीट कर लेगा जितने भी हमें उसके बनाने होंगे. So we will take the derivatives from first this and then basically the determinant of the h2 is basically the less than 0 and then h3 is basically the greater than 0. If it is following that, so we may clearly say that our function is quasi concave. So for the further goods, similarly we will use the same pattern, the first negative, then positive, then negative, then positive, and if the matrices are following this composition, this pattern, so we can say that our utility function is quasi concave. Simply we take the example of the utility function And utility function, let's suppose our utility function is under root x plus y. Okay, so we may write in this way, x power 0.5 plus y. Okay, we want to check the quasi concavity of this function. So first of all, we will make the different derivatives. Ux, so ux mean if we are taking the partial derivative, so answer will be, okay, then we want to take the uxx, the second derivative of the function, so it will be minus 0.25 x minus 1.5. okay, now we are going to take the uy. okay, so we are y, so y is a 1, and uyy, it will be the 0, and then we want to use the cross term uxy. so whatever happened here, let's mean this is the first derivative of the utility function with respect to x. Now we are going to take the derivative with respect to y, so there is no any y term, so the derivative of this will be considered as a constant, and the derivative of the constant term is equal to 0. And we will not calculate the yx because the cross derivatives are always same. So the uxy and uyx both are the same, so we can say that this is the uyx is also called the 0. So if we have different derivatives and we want to set up the Hessian matrix, and bordered Hessian basically what tells it, हम simply border बनाएंगे 0 और ux हम लिखेंगे 0.5 x 0.5, and then you will write the uy is equal to 1, and then you will write here 0.5 x 0.5, and then you will make the here. Now हम इसकी क्रॉस की बात करेंगे और सेकेंड डेरिवेटिव की बात करेंगे. तो uxx हमारे पास मौजूद है 0.25 x पावर 0.1.5, and now we will say that the u basically xy, so ये भी 0 and ये भी 0, and then you will make the uyy is also 0. Now you have to make the different Hessian matrix by using the formula of minors. So first you will make the H2. H2 means you are basically considering these four figures, and when you are considering these four figures, so you are basically making this matrix what is happening here. You can clearly see that if we will take the determinant of this and we will make the cross multiplication, so this term will be the 0 and this term will be basically H2 answer is 0.25 minus, because formula में बीच में minus आएगा, when we solve the determinant, so this term will be the cross and then minus of the formula. 0.5 into 0.5 is equal to 0.25, and then if we will add this thing to it, will be the minus 1. So this is the negative. So first condition has been satisfied, the H2 is equal to negative. Now we are going to solve the third one, and the third one is the Hessian third matrix. So what happens in the third, तो हमें 3/3 का रूल फॉलो करके हमें Hessian मैट्रिक्स को सॉल्व करना पड़ेगा. First of all, we are considering the 0, and if we are considering the 0, so this complete row and complete column, and then the remaining items are these 4 items. और हम जब इसका डिटर्मिनेंट लेंगे, लेकिन जब हम उसको 0 से मल्टीप्लाई करेंगे तो हमारी पूरी टर्म जो है वो फर्स्ट टर्म 0 हो जाएगी. ये हमारा बेसिक डिटर्मिनेंट्स रूल है. देन फर्स्ट प्लस होता है, देन माइनस आएगा, एंड देन माइनस में वी आर कंसिडरिंग बेसिकली this item, this thing, and if we are considering this thing, so this complete row and this complete column will be the removed, and then we will consider these 4 items, and we can easily say that the term is 0.5 x 0.5, but when we will make the cross multiplication with this to this and this to this, the answer will be the 0. So again the second term of the determinant also being 0. now we move for the third one, and third one basically using this thing. And if we are using this one, so this row and this column will be removed. So now we will consider these 4 items. And if we are considering so first was the plus, then minus, then plus 0.5 x power 0.5. And now we are making the cross multiplication of this to this, this to this. So this to this and this to this. So what is happening there? This term is being 0, then the of the formula minus, and then the minus is here. तो ये वाला माइनस इस वाले माइनस को कैंसिल आउट करेगा, एंड ऑटोमेटिकली यहाँ बाहर प्लस है, तो H3 में ये वाली टर्म 0 हो गई है, माइनस माइनस प्लस हो गया है, एंड 0.5 और 0.25 को जब हम आपस में मल्टीप्लाई करेंगे 5 इज इक्वल टू 0.125, ओके, एंड दीज आर बेसिकली द टर्म एंड इट विल बी द माइनस एक्स माइनस स्क्वायर. So whatever term is here, but we will focus on the sign, and the sign is the greater than 0. So basically it is following the pattern of the bordered Hessian, and now we can say that basically the utility function under root x plus y is following the quasi concavity. And just I want to tell you the one thing is very important. If we are using that first term is 0, so that's mean we are interested to check the quasi concavity. If we are not using the first term and we are starting from the f1, then f1, f2, f3, f up to fn, so this will be the for checking of the concavity, not for the quasi concavity. So now we take a example of the Cobb-Douglas function, and it is a little bit complex example. So we will check that whether the Cobb-Douglas function are following the quasi concavity or not. So now we consider the Cobb-Douglas function is a very common and very famous function. Let's suppose the utility is the function of the two commodities, and the two power, basically these are the elasticities. That means we have x raised to power 0.5 and y raised to power 0.5. So now we want to check the quasi concavity by using the bordered Hessian, and it is a very complex calculation. So for the time saving, for the easiness, and I have done all the calculation, just I will explain that what happens and how did we use the bordered Hessian. We will make the border by using the first derivatives, and then we will make the cross derivative and second derivatives in the other terms. हम सबसे पहले देखते हैं कि हमें कौन कौन से डेरिवेटिव्स की ज़रूरत पड़ेगी. तो फर्स्ट ऑफ ऑल दिस इज अ यूटिलिटी फंक्शन, एंड वी आर यूजिंग द फर्स्ट डेरिवेटिव विद रिस्पेक्ट टू एक्स, पार्शियल डेरिवेटिव. सो द यू एक्स इज इक्वल टू दिस वन, यू वाई इज इक्वल टू दिस वन, एंड यू एक्स एक्स, यू वाई वाई, यू एक्स वाई, एंड यू वाई एक्स. So all 6 derivatives we have taken here, and now we are going to plug these figures of derivative in the bordered Hessian. तो सेम जो हमने यहाँ लिए उसको यहाँ रखा, u x u y, u x u y, and u x x and u x y, and then u y x and u y y. ये जब हमने figures यहाँ plug in कर दी, now we will use the minor, and first minor is h2 and the second minor is h3. अब अगर आपके पास फर्स्ट माइनर है h2, so h2 that's mean we are just going to use these four values like this, and by using the cross derivatives, so what happens basically, we will multiply by this one, and we are going to multiply these two figures, and the minus is of the formula, and finally 0.5 into 0.5, 0.25, and then we will solve these power by the rules of indices. We'll solve the formula by using the indices, and then answer is minus 0.25 x power minus 1. हम इसको इस तरह भी लिख सकते हैं 0.25 y over x. So basically what happens, this is the less than 0 categorically. So we are following the pattern up till now, and the h2 is equal to -1, so it's less than 0. Now we will going to check that the h3 should be the greater than 0. So you have 3 by 3 matrix, and we are going to take the determinants h3. So very simple, we are using this term, and this row and this column will hide. So we will have remaining 4 terms, and we have set up this matrix by using these 4 terms. Similarly, first plus, then minus, we are using the second term like this one, and this row and this column are being hide, and then we are using these 4 values in the matrices. And then finally the third term, and this matrix will multiply with this term. So this is the opening of the 3 by 3 determinant by using this function. Finally, just we will make the algebraic calculation, algebraic solution. This whole term will be 0 because it will going to multiply with 0. So this one is completely equal to 0. Then we are keeping the same term, minus 0.5 x power minus 0.5 y power 0.5, and now we are going to first multiply by using the cross term, and we will use the minus sign of the formula. So if these terms are going to multiply, so the answer is minus 0.125 y power minus 1, and this is the minus of the formula, and इन टर्म्स को मल्टीप्लाई करने के बाद हमें आंसर आता है 0.125 y पावर -1. तो हम इसी पैटर्न को यूज करते हुए ये वाला मैट्रिक्स भी सब सॉल्व करेंगे. सो वी विल गेट these thing. Now this term has been removed, and now we have only basically we have to solve this one and this one. So we are just going to multiply by these figures to these figures, so the minus sign is the outside. So it will make these two terms positive, और आपने देखा कि दोनों terms positive हो गई, and this is already positive, and ये दो terms भी automatically positive हो गए. And finally we got all terms are same, this one, this one, this one, this one, by using the multiplication, simple algebraic plus minus. And then if we are going to add all these terms, so the answer is 0.25 x power minus 5 y power minus 5. इन दोनों को आप नीचे ले आए, so 0.5 को ऊपर रहने दें, and then x5 आपके पास नीचे आ जाएगा. Whole term is positive, then that's mean h3 is a greater than 0. So very categorically we can say that this Douglas function is quasi concave. I hope that you learn about it, how to check the quasi concavity of the utility function. So please subscribe our channel for more videos. Thank you.